Hi everyone. Let's go ahead and work on Module 7, Lesson 2 today. So we're exploring more meanings of rate of change. You'll see this entire packet is all about rate of change, which we learned in the previous lesson, that is just the slope. There's actually quite a few different names for it. Average rate of change, slope, change in y over change in x. So those are some of the more common ones. So here we have some hexagons. Consider sequence of figures given in sequence A. So figure 1, figure 2 has 2 hexagons, figure 3 has 3 hexagons. So use sequence A to complete the table given below. So do you all remember from previous classes that perimeter means distance around the outside? So the perimeter of the first one is 1, 2, 3, 4, 5, 6. And we don't know if it's 6 units, 6 feet, 6 inches. So we'll just write 6 units. Okay, I'm going to turn my phone off because I just realized I forgot to do that. I just heard it make a noise. Okay. And then unit 2, a lot of students mistakenly think, oh, it's going to be 12. Well, it's not because they share a side. So if this is 1, sometimes when it's busy, I like to mark it 1, 2, 3, 4, 5. This is not the area around the outside, so we can't count that. 6, 7, 8, 9, 10. So it's 10 units because we lost 2 here, 1 from the right, 1 from the left, and that's why it's only 10. So you have to understand the definition of perimeter to understand that. So perimeter is the distance around the outside. If this was a building, you would be walking out here. You would not go in there. So this one, it's right where we start. So 1, 2, 3, 4, 5. Don't go inside. 6, 7, 8, 9, 10, 11, 12, 13, 14. So what we're trying to get you to notice here is that there's a pattern. As we add a figure to the sequence, the perimeter is increasing by 4 units. So for each figure added to the sequence, the perimeter increases by 4 units. That's actually called the slope, because isn't that the rate of change? Yep. So we're going to talk about that at the bottom of the page, but let's go ahead and fill in the table. So perimeter with 1 figure was 6, with 2 it was 10, with 3 figures is 14, and we'll just write units up here so we don't have to keep writing it like we did on the other one. So if we don't know if it's inches or feet or whatever, we just say units. And so if we follow the pattern, which is add 1 to the figures, which results in adding 4 to the perimeter. So as we add 1, we add 4 and get 18. As we add 1, we add 4 and get 22, 26, 30, 34, 38, and 42. So add 4, 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 add 4. So the difference in perimeter is plus 4 units all the way down, right? So how we do the difference is we take the second minus the first. So 10 minus 6, it's just like the slope formula. Second y minus the first y, 4 over second x minus the first x, 1. So the successive difference, change in perimeter, is plus 4 units. So now let's put that into words. I'll give you guys a chance to copy that. I didn't realize I was off the thing. I wish I had like a horn that you guys could beep that would go, hey, you're off the page. So how would you describe the change in perimeter? So we want to do it like a slope problem because change in perimeter is slope. So for each figure added in the sequence, the perimeter increases. Well, here, we'll do it down here. We can use this table. So for each figure added in the sequence, the perimeter, and we always have to say increases or decreases when we're talking about slope. So we would say the perimeter increases by 4 units. So for each is another way of saying per. You could say $1 per dozen, or you could say $1 for each dozen. So sometimes this just sounds better. So for each figure added to the sequence, the perimeter increases. That tells us that the slope is positive. So when something, whoops, see when I talk and write, bad combination. So that tells us that it's going up rather than going down. So the perimeter increases by 4 units. So for each figure added to the sequence, the perimeter increases by 4 units. So you could say the perimeter increases by 4 units per each figure added to the sequence. But I just thought this sounded better. So for each is another word like per. You can write that here on the side, because remember how I said whenever we're talking about rate of change, we always have to use the word per. For each is a per word. Okay, let's go ahead and turn the page. I like this packet. It's a pretty fun packet. Kind of drills home the whole idea of rate of change. Okay, so activity 2, distance versus time. Ashley set out on a road trip and kept a log of her time and distance traveled as shown. She set her car on cruise control during the trip and drove nonstop. And that's important because in order to do how fast you're going, you do have to have a continuous speed. I mean, you could get an average rate of change, or you can set your cruise control and have a steady rate. So describe how Ashley's distance traveled changed with respect to time. So when we added in 2 hours, for each additional 2 hours, her distance increased by 150. And remember how we always say y per x? So this is distance traveled change. So that tells me it's going to be a rate of change with respect to time. I guess that's part of them. So in words, we could say her distance increased by 150 miles per 2 hours traveled. So 150 miles. Remember how we learned this is per 2 hours traveled? Remember how we said that? It has to be y per x from our first lesson. So y, 150 miles per change in x was 2 hours. But we also talked in the last lesson that we don't want to know how far she went in 2 hours. We need miles per hour. I want to know how fast was I going. Well, I can easily make this into 1 by dividing both of these by 2. And so then I get 75 miles per 1 hour. And that's what we generally want for rate of change unless instructed otherwise. We want it per 1 unit of time, not per 2 units of time. So y Per is replaced with the fraction bar, x. So that's what this looks like, just in fraction form. So Ashley was driving at 75 miles per hour. So that's how her distance changed. For every hour, she drove 75 more miles. So that means she had her cruise control set at 75 miles per hour. And you can see the pattern continued, add 150, add 2. So it didn't matter which 2 points we picked. I usually just start with the first 2, but we could have picked any of them. So Ashley was driving at 75 miles per hour. I don't think we need at. I could have written it like that. Ashley was driving 75 miles per hour. Okay. So now that we know her rate, distance traveled change, this is called the rate of change. Now can't we fill in the table? Because 75 miles per hour means per 1 hour. So in 1 hour, she drove 75. 1.5, we would need the calculator. So this was 1 times 75. So this will be 1.5 times 75 and 2 times 75 and so on. We don't need to write them all down. Okay, so let's get our calculator. So 1.5 times 75 is 112.5. And we don't have to put miles on it because I already have it labeled there. 75 times 2 is 150. 75 times 2.5, I can just hit my up arrow, change that to a 2. 187.5. And for 3 hours, 75 times 3, 225. So do you see how finding the rate allows us to do this? Remember when we did this on the candy store problem? We found out how much 1 pound of candy costs, and that allowed us to fill in the whole table. Here we found out how much we increase our distance in 1 hour, so that's allowing us to do this. So change in y over the change in x. The y increased by 150, the x increased by 2, and then we simplify. Okay, so let's go ahead and change that to 3. 262.5. 75 times 4 is 300. And change that to a 4. And 337.5. And then 75 times 5 is 375. I'm going to go ahead and do 6 while this one's here. 75 times 6, 450. And then 75 times 5.5 is 412.5. So what they're trying to get you to understand is by finding the rate of change, that means a change in 1 hour or in 1 pound of candy, that will allow you to draw a graph and complete a table. Okay, let's go ahead and look at the next page. We only have about 30 seconds. So yeah, I think we'll start here on the next video, okay? Because I don't want to rush through this in 30 seconds. So I'll see you in the next one. Bye.